Hello friends, and welcome back in today's video series part 1, where we shall see how to use the Proteus software. We shall work on the assumption that you already have the software installed in your machine. So before we get started, my name is Kenija, and in this channel I share with you my experience as far as electrical and electronics engineering is concerned. Without wasting much of your time, let's get started. So open your software. Once you open your software, this is how the interface looks like. You have here open a project. This is if you have created a project before. You have new project, new flowchart, and open sample. If you don't want to go through the process of creating a new project, you can come here where you see this icon schematic capture. You click on it and it's going to direct you directly on the front panel where you can do your designs and all the rest. But we are going to follow the normal procedure, which is creating a new project. So come here and click on creating new project. Once you do that, you have to insert the project name. And you can equally browse to change the location where the project will be saved. So after doing that, just click next. And you see create a schematic form for create. You can see here it says create a schematic from the selected template. Just allow it to default and go to next. And here, do not create a PCB layout. So this is where if you want to create a PCB from your schematic, you can select create a PCB layout. But in this video, we are not going to do any PCB. So let's allow it to do not create a PCB layout. And continue next. Just continue clicking next until you click finish. So here is the interface of Proteus. And as you can see, where you see this small grid, here is where you place your component and do the design of your project or of your circuit. Now, if you want to select any component, you come where you see this P icon. Here you can search for any component you want, so far as it is inside the library of the Proteus software, unless you will have to install that component you want. So let's say, for example, we want the admeter. You see, you have various admeters. Admeter is a microcontroller used for Arduino. Or let's say instead of the admeter, we want the Arduino. You can see here we have Arduino Mega, Arduino Nano, we have Arduino Uno, and just like that, you select what you want. And as you can see on the left side of our screen, all these icons you can see here are I don't know if I should call it design icons, because if you come here, for example, you have various components that you need. If you want to draw, for example, a square, a circle, and so on, you have here to include the text. If you want to write the text on a particular part of your circuit, you can do that here. And here you have a selection of ports like the ground and so on. Here you have input, DC input, pulse, and all the rest. So I think the best and fast way to learn this software will be to design a simple project or a simple circuit so that you can quickly get acquainted with all of these various parts. So we are going to design a full bridge rectifier circuit to convert AC signal into DC and then use that DC to shine on an LED. So what we need, we come here to the P icon. The first thing we are going to use is a bridge. Now you can use diodes, but for the purpose of this video, we don't want the video to be long. So we are going to use a bridge. Just double click on this generic bridge, and that is it. Then we also need a transformer. So these are the various transformers we have here. We have tap change transformer and all of the rest. So we are going to take this last one. So you double click on it. We are also going to need, you also need a sine wave. Sine, so just search for V sine. And here it is. You double click on it. The next thing you are going to need is a capacitor for filtering. So we are going to use the electrolytic capacitor, the generic. So let's take that, and we're equally going to need a voltage regulator. So we are going to use the 7805. This regulator has output of 5 volts. So here it is. Double click on it. We are equally going to need a LED. So I'll precise the blue LED, but you can take any other color of your choice. So this is my LED, and I think the last component we need is a resistor. So we are going to use this default resistor and just hit the enter key on your keyboard. So these are the components we need. Now to place a component in this design area, simply come and select the component. Let's say for example the bridge. I select the bridge, then I will come on the screen and left click, and you can see the component appears immediately. Then you click again for a second time and the component is placed where you want it to be. So the next is the V sign, which is the input, and we are going to put it here. After the input, we want to put a transformer. The transformer is there to step down the input AC signal to a desirable output AC, which can be converted easily. So after the bridge now, what we want to put is a capacitor. Now to rotate this capacitor, simply come here where you see these two arrows. You can see rotate clockwise and rotate anti-clockwise. So I want to rotate this capacitor clockwise. I'll click on the one above, and that is it. And I will come and place it here. Once I do that, the next thing I want to place after the capacitor is my regulator. I'm equally going to rotate this regulator in this direction, and I will place it here. After the regulator, what we want to put is the resistor. Then after the resistor, we are going to put our LED. Place your LED. And now what is left is for us to out and to set in our initial values. So we are going to out it just like this. Okay, to connect your components together, you simply come at the terminal of any of the components you want to connect, and you click on it and just drag. And when you reach the next terminal to which you want to connect, just click again, and the connection is done. So we are going to set in our parameter. For the resistor, we want to put a resistance of 220 ohms. So for the capacitor, we are going to put the capacitance of 470 microfarads. Then now, we are going to put the transformer 10 ratio. As you can see here, it is 1. We have to modify that. We are trying to step down a 220 AC to a 12 volt AC. So if you take 220 divided by 12, you have 19.666. Many 6 as possible. So let's just make it out of that. Now you come to the V sign, you have to input the value of your AC signal here. You can see you have DC offset. You are going to allow that one to default amplitude. Here you are going to put the amplitude of 311. This is because the amplitude is different from the root mean square value. 220 volt is the root mean square, whereas the amplitude is 111. That is 220 times 1.334 or something. Yes. So the frequency, we are going to put 50 Hertz, and we are going to allow every other thing to default setting, and we click OK. Now in Proteus, another important thing you should note is that you have to always put a reference or a common ground whenever you design a circuit. If not, it is not going to work. So we are going to come here when you see this terminal node, and you are going to click on ground. Then you take the ground and connect it here. So this is going to be our reference point. Now the next thing I would like us to do is to place some voltmeter to see the various output voltages at each stage of the circuit. So we are going to come here node here instead, and you can see you have DC voltmeter. Click on that and come and place it here. We want to see the output after the regulator, and we equally want to see the output after the bridge rectifier, after the rectification. So we are going to put another one here. Then we equally want to see the AC voltage after the transformer. So you take AC and you place it here. Now, with all of this done, I think our circuit is ready and we can run the simulation. So to run the simulation, simply come down here where you see this icon like a triangular shape, the play button actually. So just click on it and you can see that immediately the LED starts shining. Yes, let me try to zoom in so that you can see. Okay, so I am zooming the circuit. You see, you can see that after the transformer we have 11.33, that is close to 12 volt AC. So you can modify that by simply coming to your V sign. Let's put something like 320. Okay, you see now we have 11.6, just like that. So if you put, I think 380, you might have close to 12. You might have 12 volt, but 11 is really much. 11.6 is much closer to 12, so we can allow it like that. Now after the bridge, you see that we have a voltage of 14.5 volt DC. Yeah, DC. But one thing you have to note is that this voltage is not that stable. So we are using a voltage regulator here after the bridge rectifier to step down and to stabilize this 14 volt to constant 5 volt, as you can see here. Now this 5 volt now is passed through the resistor of resistance 220, which then shine on the net, as you can see here. So this is basically how this circuit works. Okay, so we have come to the end of this video and we hope you got some value from this. If you have any question, make sure to drop them down in the comment section below and we'll do our best to pertain to you. Remember, this is a video series, and throughout this series we are going to design and do cool projects using the Proteus simulation software. So if you are interested in learning electronics and learning how to use the Proteus software, make sure to subscribe to this channel so you won't miss any of our next video throughout the series. Thank you all for watching and see you in the next one. Peace.